Okay, I'm just going to talk you through your matrices, your bubble diagram. You already have this in the revision section of Google Classroom, but just want to make sure that all has come back to you. If you're adding or subtracting matrices, you just add the corresponding elements. If you're multiplying matrices, there are two ways of doing it. If you multiply by a scalar, that's you multiply each element by the scalar. Scalar is just an ordinary number. If you're multiplying it by a matrix itself, you lift and twist. So, adding, subtract, is add corresponding ones. Multiplying by a scalar, you, maybe I'll just actually show you here. So, if you're adding the corresponding elements, so if you had this kind of matrix, you would just go 2 add minus 1, 3 add 3, 5 add 4, 4 add minus 1. Okay, by a scalar. So in this wee one here, say if you had 2, 3, 4, 5, 2, you just multiply everything by 2. So 6, 10, 8, 4. Okay? If you're doing this lift and twist, so what I mean by that, 2, 1, 3, 2, and we'll just do a 2, 1. So you lift and twist. So that 2 matches up with this 2. So 2 2s are 4. And this one matches up with this one, and you add them. And then do the bottom row. So I'm in the second row, first column. So lift and twist. So 6 add 2. And then you tidy those up. So that's your lift and twist. If you're asked to divide by a matrix, you can't. So what you do is you multiply each side by the inverse. And the inverse, two types. You could be asked to divide, to find an inverse. So e.g., if A is 3, 2, 5 minus 1, and you want the inverse. First of all, the inverse is written with v minus 1. It's 1 over determinant. You switch the main diagonal and you change the signs in the subdiagonal. And the determinant is the main diagonal, take away the subdiagonal. So it's minus 13. So your determinant is 1 over minus 13, minus 1, minus 2, minus 5, 3. And if you have got simultaneous equations, you write them out in matrix form, and then you find the inverse, multiply each side with the inverse, and the big thing there to remember is at the end you must write x equals or y equals. Now I have all these questions answered for you. I'm just going to run through how you do them. The first one, P take away Q. Just take away the corresponding elements. X is what you don't know and equals R. So I want to get rid of this inverse. You cannot bring it over and divide. So I want to get rid of this matrix. You can't bring it over to divide, so I need to find the inverse of that. So this is me finding the inverse. Determinant is 8, take away 5. 1 over determinant, switch the main diagonal, change signs in the sub. Then you pre-multiply each side by this inverse. So can you see it? It goes in here, and it goes there. Do your lift and twist. This side should collapse down to the 1, 0, 0, 1, which is your 1 matrix, and this side should tidy up and just take it through at the end. The next one we're going to look at is question from 2017. Again, I'm just going to talk you through it. It's a very similar question. 2 times the first, take away the q. So that should be straightforward enough. P squared. Remember, p squared means p times p. So write out your p times p. It's not squaring each element, it's writing them out like this. Then do your lift and twist and tidy up. Part 3. When it says hence, you must use your previous answer. So half of r plus q you know, p squared you've worked out. This matrix is adding, you can easily bring that over to take it away. Then you're left with a half r. To get r on its own, you bring the 2 over and times everything by 2. Number 5. You always know a vector because it's done in bold. A vector is just a matrix with 1 column. So it's the same thing. So 2 times x we don't know, plus c that we do, equals a that we do know, take away 4b. So I'm going to do this, times that by 4 and then take them away. I'm bringing this matrix or vector over to our side. It becomes a take away. Tidy it up. I want rid of this 2, so you bring it over and it divides. Now, number 7, AX equals B. So write out what you know. You know your A, your X, and your B. You want rid of this matrix. This matrix is multiplying. You can't bring it over as a division. You're not allowed to divide. So the way you do that is you find the inverse of this, the one you want rid of. So determinant is main diagonal, take away subdiagonal. The inverse is 1 over determinant. Switch the main diagonal and change the signs in the other. Now you've got the inverse. Pre-multiply each side here and here by this inverse. So do your lift and twist. Now you won't get any marks for doing the left-hand side, but why I like doing the left-hand side is that if it comes down to the 1, 0, 0, 1 matrix, I know my inverse is correct. So it's a wee checking mechanism. This side you must do. So you just do your lift and twist. So 4 times 19, take away 6, 11, and so on. And then take your determinant at the end, or 1 over your determinant. Next paper we're going to look at is 2016, if I can find it. So it's A minus 3C. So put in what you know, A minus 3C, and just work that out. The next wee one is A times B. So put in what you know, your A and your B. Now this one's more tricky. If you lift and twist, it's only one value you're lifting. So 2 times minus 1. Then you're moving across, 2 times 2. Now you're in the bottom row, 3 times minus 1. Now you're moving across, 3 times 2 is 6. Number 5, write out what they've given you, okay? Multiply through by P and multiply through by 3. So 5P take away 3 equals 7. You can work out P. Do the same for the bottom row. 2P add 3Q equals minus 5. You know what your P is. You can then work out your Q. Number 8 is find the inverse of this. So I need the determinant. So it's main diagonal minus 8, take away 3. So it's 1 over inverse. Switch the main diagonal and change the signs in the sub. And that's that one done. Now it says hence. So you're going to use your previous answer there to solve these simultaneous equations. Now I mentioned this at the very beginning. You must write it out in its proper form. So it's 4, 3, 1 minus 2, x, y, 34 and 3. Always write it out like that. I want rid of this one because it's multiplying. When I bring it over, it wants to divide, which you can't do. So it's the same as before. Pre-multiply each side by the inverse. And this is what you found in part 1. So use your answer for part 1. Now you can see me checking the left-hand side out. You don't have to do that, but you must do this side. And at the end, it's really, really important that you write x equals and y equals. Okay, next wee one. Just add the elements. P add 2p is 3p, and 3 add r doesn't cancel down. You leave it like that. This is a lift and twist. Now look at my fingers. Lift, twist. So you see the way the 2 matches with the 4 and the 3 matches with the minus 1. So it's 3 take away. So 8 take away 3 is 5. Wait, quick check. I have got 1 row and 2 columns. Over here, I've got 2 rows and 1 column. My end answer should be a 1 by 1, which it is. Now, if you compare it to part C, if you lift that row and twist it, there's only one match, so it's 8. Now move across, 10. Down to the bottom row, 12, then move across. And if you look here, you've got 2 rows. Rows are what go across, and you have 1 column. So you have 1 row and you have 2 columns. Look at the end numbers. My end result should be a 2 by 2, which it is. Number 7 is a backwards one. Okay, you're given the inverse. So you can look straight at that and see the determinant is 5. Switch the main diagonal, just switching it back, and change the signs in the sub. That's you. So it's a wee doing it back to front. And For the last one, inverse, so hopefully that's straightforward enough, and just writing them out, the simultaneous equations, writing them out in matrix form, pre-multiply by the inverse. Hopefully that's okay, and make sure you give your answers x equals y equals at the end.